Hello friends, in previous video we have seen practice problem on determinants, in which we have seen how to calculate the value of determinant for 2 by 2 as well as 3 by 3 matrix. Now in this video we will see practice problems on properties of determinants as well as applications of determinants to coordinate geometry. Problems based on properties of determinants. Without expanding, evaluate the determinant 41, 1, 5, 79, 7, 9 and 29, 5 and 3. Now, in this determinant there are a bit bigger numbers. So, if we directly start expanding this determinant along with any row or any column, then we may need to perform a bigger multiplication. Hence, it is easier to find out the value of this determinant without expansion, that is without actual multiplications, by using properties of determinants. So, let us say delta is equal to 41, 1, 5, 79, 7, 9 and 29, 5 and now if we rearrange this determinant by using C1 will become C1 minus 8 into C3. So, 41 minus 8 into 5 that is 41 minus 40 is equal to 1. So, first row first column element will become 1. Then 79 minus 8 into 9, that is 79 minus 72 is equal to 7, and similarly 29 minus 8 into 3 is equal to 29 minus 24 is equal to 5. Hence, delta is equal to 115, 779 and 553. Now, if we observe in this determinant, delta C1 is equal to C2. Hence, we can say that value of delta is equal to 0, because there is one property of the determinant in which it is said that if there are any two rows or any two columns are identical in any of the determinant, then the value of this determinant is equal to 0. Hence, determinant 41, 1, 5, 79, 7 and 9 and 29, 5 and 3 is equal to 0. Show that determinant 1 BC A into bracket B plus C, 1 CA B into bracket C plus A and 1 AB C into bracket A plus B is equal to 0. Now, let us suppose delta is equal to the given determinant, that is delta is equal to 1 BC A into bracket B plus C, 1 CA B into bracket C plus A and 1 AB and C into bracket A plus B. So, we will expand column 3 now, that is 1 BC AB plus AC, 1 CA and AB plus BC, 1 AB and AC plus BC. Now, if we perform the operation, that is C3 will become C3 plus C2. Then we have the revised determinant delta is equal to 1 BC AB plus BC plus AC, 1 CA AB plus BC plus AC and 1 AB and AB plus AC plus BC. So, from column 3 we can find out AB plus BC plus CA common, then value of delta will be AB plus BC plus CA into determinant 1 BC 1, 1 CA 1 and 1 AB 1. Now, in this determinant also C1 is equal to C3, hence value of determinant is equal to 0 and hence value of delta will become 0, that is AB plus BC plus CA into 0 is equal to 0. Hence, it is proved that the value of given determinant, that is 1 BC A into bracket B plus C, 1 CA B into bracket C plus A and 1 AB C into bracket A plus B is equal to 0. Show that sums of the roots of the equation determinant x minus 6 minus 1, 2 minus 3x, x minus 3, minus 3, 2x and x plus 2 is equal to 0. Now, it is given that the value of the given determinant is equal to 0. Hence, we can write x minus 6 minus 1, 2 minus 3x, x minus 3 and minus 3, 2x, x plus 2 is equal to 0. Now, we will expand this determinant along with, let us say, first row. So, minus 1 raised to 1 plus 1 into x into determinant minus 3x, x minus 3, 2x and x minus 2 plus first row second element. So, minus 1 raised to 1 plus 2 into minus 6 into determinant 2 x minus 3 minus 3 and x plus 2 plus first row third column. So, minus 1 raised to 1 plus 3 into minus 1 into determinant 2 minus 3x minus 3 and 2x is equal to 0. So, right hand side is given as 0. Now, minus 1 raised to 1 plus 1 will become into x will become plus x. So, plus x into bracket minus 3x into x plus 2 minus 2x into x minus 3. Now, minus 1 raised to 1 plus 2 into minus 6 will become plus 6 into bracket 2 into x plus 2 minus minus 3 will become plus 3 into x minus 3 and minus 1 raised to 1 plus 3 into minus 1 will become minus 1 into bracket 2 into 2x is equal to 4x minus minus 3 into minus 3 will become minus 9x is equal to 0. That is x into minus 3x square minus 6x minus 2x square plus 6x plus 6 into bracket 2x plus 4 plus 3x minus 9 minus 1 into bracket 4x minus 9x is equal to 0. Hence, x into bracket minus 5x square plus 6 into bracket 5x minus 5 minus 1 into bracket minus 5x is equal to 0. Hence, we have got minus 5x cube plus 30x minus 30 plus 5x is equal to 0 minus 5x cube plus 35x minus 30 is equal to 0. Now, if we divide whole equation by 5 by minus 5, then we have got x cube minus 7x plus 6 is equal to 0. Now, it is given that all the roots of this equation are real and hence sum of roots is equal to minus coefficient of x square upon coefficient of x cube. Now, in the given expression there is no term of x square, hence coefficient of x square is equal to 0, that is 0 upon coefficient of x cube is 1. So, minus 0 upon 1 is equal to 0 and hence it is proved that sum of the roots of the given equation is equal to 0. Solve the determinant x plus a, b, c, a, x plus b, c and a, b, x plus c. Now, let us say delta is equal to determinant x plus a, b and c, a, x plus b and c and a, b and x plus c. Now, we will perform a column operation of C1 is equal to C1 plus C2 plus C3. So, delta will be equal to x plus a plus b plus c, b and c, a plus x plus b plus c, x plus b and c and a plus b plus x plus c, b and x plus c. Now, from this first column we can take x plus a plus b plus c common. So, delta will be equal to delta is equal to x plus a plus b plus c into determinant 1bc, 1x plus b c and 1bx plus c. Now, we will apply the row transformation as R1 will become R1 minus R3, that is 1 minus 1 is equal to 0, b minus b is equal to 0 and c minus x plus c is equal to minus x. Hence, delta will become x plus a plus b plus c into determinant 0 0 minus x, 1 x plus b and c and 1 b and x plus c, that is row 2 and row 3 as it is. This operation we have done by R1 will become R1 minus R3. Now, we will expand this determinant along with first row. So, x plus a plus b plus c into minus 1 raised to 1 plus 3 into minus x into determinant 1 x plus b, 1 and b. That is delta is equal to x plus a plus b plus c into, now minus 1 raised to 1 plus 3 is plus x. So, minus x as it is. Now, b into 1 is b and minus 1 into x plus b is minus x minus b. Now, this plus b minus b will get cancelled. So, we will have delta is equal to x plus a plus b plus c into x square. So, the value of the determinant x plus a, b and c, a x plus b, c and a, b, x plus c is equal to x plus a plus b plus c into x square. Moving to next problem. Solve the determinant 1a a cube, 1b b cube and 1c c cube where b is not equal to c. Now, let us say delta is equal to 1a a cube, 1b b cube and 1c c cube. Now, we will perform row operation as R1 will become R1 minus R2. Hence, delta will be 1 minus 1 is 0, a minus b is a minus b and a cube minus b cube. Row 2 and row 3 as it is, that is 1b b cube and 1c c cube. Now, we will perform one more operation as R2 will become R2 minus R3. Hence, delta is equal to, now first row as it is 0 a minus b, a cube minus b cube, 1 minus 1 is 0, b minus c and b cube minus c cube. Now, R3 is again as it is, that is 1c and c cube. So, we have, now we will factorize column elements as in a cube minus b cube and b cube minus c cube. So, we will have delta is equal to 0 a minus b. Now, what are the factors of a cube minus b cube? That is a minus b into bracket a square plus ab plus b square. Similarly, second row will become 0 b minus c and factors of b cube minus c cube as b minus c into bracket b square plus bc plus c square, and third row as it is, that is 1c and c cube. Now, we will take a minus b and b minus c common. In column 2 and column 3, a minus b is there and in column A there is 0. So, we can take from row 1 a minus b common and from row 2 b minus c common. So, delta will become a minus b into b minus c into determinant 0, 1 and remaining factor, that is a square plus ab plus b square. Second row 0, 1, b square plus bc plus c square and third row as it is 1c and c cube. Now, we will expand this determinant. So, delta is equal to a minus b into b minus c into, now we will expand this along with column 3. So, directly we can have minus 1 raised to 3 plus 1 into b square plus bc into c square minus a square plus ab plus b square. So, upon simplification we have got delta is equal to a minus b into b minus c into minus 1 raised to 3 plus 1 into bracket b square plus bc plus c square minus a square minus ab minus b square. Now this plus b square minus b square will get cancelled. So we will have a minus b into b minus c into bracket bc plus c square minus a square minus ab. We will try to factorize this term. So we will rearrange as bc minus ab plus c square minus a square. So we have a minus b, b minus c as it is. Now bc minus ab, we can take b common. So into bracket c plus a, and c square minus a square can be factorized as c plus a into c minus a. So we can take this c minus a common. So delta will become a minus b into b minus c into c minus a into bracket a plus b plus c. So the value of this determinant delta is equal to 1a a cube, 1b b cube and 1c c cube is equal to a minus b into b minus c into c minus a into a plus b plus c. That is our final answer. Now we will see word problems, that is applications of determinants to coordinate geometry. Find the area of triangle with vertices a 5 4, b minus 2 4 and c 2 minus 6. Now we know that area of a triangle with vertices x1 y1, x2 y2 and x3 y3 is given by the formula delta is equal to 1 by 2 into determinant x1 y1 1, x2 y2 1 and x3 y3 1. So for the given triangle with vertices, let us say a is equal to 5 4, b is given by minus 2 4 and c is given by 2 minus 6, then delta will be 1 by 2 into determinant 5 4 1 minus 2 4 1 and 2 minus 6 1. Now either you can directly find out the value of this determinant or you can simplify to reduce the calculations. Let us suppose here I have done R1 will become R1 minus R2 and R2 will become R2 minus R3. So I have got delta is equal to 1 by 2 into bracket. Now R1 will become R1 minus R2. So 5 minus minus 2 is 4, 4 minus 4 is 0 and 1 minus 1 is also 0. Now for the second row R2 will become R2 minus R3. So minus 2 will become minus 4, 4 minus minus 6 will become plus 10 and 1 minus 1 will become 0 and R3 as it is. Now we will expand this determinant along with first row. So delta is equal to 1 by 2 into bracket minus 1 raised to 1 plus 1 into 7 into determinant 10 0 minus 6 and 1. After that minus 1 raised to 1 plus 2 into 0, you can, it's okay if you don't write next two terms in the expressions because we know that the element is 0. Hence minus 1 raised to 1 plus 2 into 0 into determinant minus 4 0 2 and 1 plus minus 1 raised to 1 plus 3 into 0 into determinant minus 4 10 2 and minus 6. Hence it is equal to 1 by 2 into bracket. Now minus 1 raised to 1 plus 1 is plus 1 into 7 and value of the determinant is 10 minus 0, that is 10. Hence 10 into 7 is 70, 70 divided by 2 is 35 units. So area of triangle with vertices A 5 4, B minus 2 4 and C 2 minus 6 is equal to 35 square units. If the points A 0, 0B and 1 1 are collinear, prove that A plus B is equal to AB. Now it is given that the given points are collinear. Hence we can say that if we form a triangle with these vertices, assuming that these 3 points are vertices of some triangle, then area of that triangle will be equal to 0. Now we know that area of a triangle with vertices x1, y1, x2, y2 and x3, y3 is equal to delta, where delta is equal to 1 by 2 into determinant x1, y1, 1, x2, y2, 1 and x3, y3, 1. Hence, we can say that area of triangle with vertices a0, 0b and 1, 1, if it is equal to delta, then the value of this delta is 0 as the given points are collinear. Hence, 1 by 2 into determinant a01, 0b1, 1, 1, 1 is equal to 0. Now, we will expand this along with row 1. So, 1 by 2 into bracket minus 1 raised to 1 plus 1 into a into determinant b1, 1, 1 plus minus 1 raised to 1 plus 2 into 0 into determinant 0, 1, 1, 1 plus minus 1 raised to 1 plus 3 into 1 into determinant 0b, 1 and 1 is equal to 0. Hence, 1 by 2 into bracket a into bracket b minus 1 plus 1 into minus b is equal to 0. That is, ab minus a minus b is equal to 0. Hence, minus a minus b is equal to minus ab, that is a plus b is equal to ab, and hence it is proved that a plus b is equal to ab. We will move to next problem. Find the value of lambda so that the points are 1, minus 5, minus 4, 5 and lambda 7 are collinear. Now again, if the given points, from the given points if we form a triangle, then if the points are collinear, then the area of such a triangle will be 0. Hence, we know that area of a triangle we can calculate with the vertices, as in area of a triangle with vertices x1, y1, x2, y2 and x3, y3 is delta, where delta is equal to 1 by 2 into determinant x1, y1, 1, x2, y2, 1 and x3, y3, 1. Now here in this case, points, vertices of the coordinates are given, that is 1, minus 5, minus 4, 5 and lambda 7. So, we can say that 1 by 2 into determinant 1 minus 5, 1, minus 4, 5, 1, lambda 7, 1 is equal to 0. Now, let us say R1 will become R1 plus R2. So, delta is equal to now 1 by 2, 1 plus minus 4 is equal to minus 3, minus 5 plus 5 is equal to 0 and 1 plus 1 is equal to 2. Row 2 and row 3 as it is, minus 4, 5, 1, lambda 7 and 1. Now, if we expand this along with, let us say, row 1, we will have 1 by 2 into bracket minus 1 raised to 1 plus 1 into minus 3 into determinant 5, 1, 7, 1 plus minus 1 raised to 1 plus 2 into 0 into determinant minus 4, 1, lambda and 1 plus 1 into bracket plus 1 raised to 1 plus 3 into 2 into determinant minus 4, 5, lambda and 7 is equal to 0. So, we have 1 by 2. Now, this expression will become 0. So, minus 1 raised to 1 by 1 plus 1 is plus 1. So, minus 3 as it is. So, 1 by 2 into bracket minus 3. Now, value of this determinant will be 5 minus 7. Now, minus 1 raised to 1 plus 3 is plus 1. So, plus 2 into bracket. Now, value of this determinant will be minus 28 minus 5 lambda is equal to 0. So, we have got the expression as 1 by 2 into bracket minus 3 into 5 minus 7 plus 2 into minus 28 minus 5 lambda is equal to 0. That is minus 3 into 5 minus 7 plus 2 into minus 28 minus 5 lambda is equal to 0 if we send 2 to the right hand side. So, 6 minus 56 minus 10 lambda is equal to 0. Hence, minus 10 lambda is equal to 50, that is lambda is equal to minus 5. So, final answer for this question is lambda is equal to -5. Using the determinants, find the area of triangle whose vertices are 1, 4, 2, 3 and -5, -3. Are the given points collinear? So, first of all we need to find out area of the triangle whose vertices are given points 1, 4, 2, 3 and -5, -3. We know that area of triangle with vertices x1, y1 as delta is equal to 1 by 2 into bracket x1, y1, 1, x2, y2, 1 and x3, y3, 1. So, we will put the given values into the expression as area of the given triangle delta is equal to 1 by 2 into bracket 1, 4, 1, 2, 3, 1 and -5, -3, 1. Now, either you can directly solve or you can reduce the determinant. Here I have reduced the determinant as applying the operations R2 will become R2 plus R3 and R1 will become R1 minus R3. So, delta is equal to, now R1 is R1 minus R3. So, 1 minus -5 is +6, 4 minus -3 is +7, 1 minus 1 is 0 and R2 will become R2 plus R3. So, 2 plus -5 is -3, 3 plus -3 is 0 and 1 plus 1 is 0 and R3 as it is -5, -3 and 1. Now, we will expand this determinant along with row 1. So, delta is equal to 1 by 2 into bracket -1 raised to 1 plus 1 into 6 into determinant 0, 2, -3, 1 plus -1 raised to 1 plus 2 into 7 into determinant -3, 2, -5 and 1 plus -1 raised to 1 plus 3 into 0 into determinant -3, 0, -5 and -3. So, value of this part of the expression is 0, hence 1 by 2 into bracket. Now, -1 raised to 1 plus 1 is plus 1. So, plus 6 as it is. Now, this value of this determinant 0, 2, -3, 1 will become minus 6, that is plus 6. Hence, we have 1 by 2 into bracket 6 into 6. Now, this -1 raised to 1 plus 3, 1 plus 2 is -1 into 7. So, -7 and value of this determinant is -3 into 1 is -3 minus -5 into 2, that is plus 10. So, we will have delta is equal to 1 by 2 into bracket 6 into 6 minus 7 into -3 plus 10. Delta is equal to 1 by 2 into 6 into 6 minus 7 into -3 plus 10, that is delta is equal to 1 by 2 into 36 minus 49, that is delta is equal to 1 by 2 into mod minus 13 is equal to 6.5 square units. So, area of the triangle is 13 by 2, that is 6.5 square units, and as this value is not equal to 0, hence we can say that the given points are not collinear. So, in this video we have seen practice problems on properties of determinants as well as applications of determinants to coordinate geometry. Thank you. In next video we will see few more problems on determinants.